In order to better support multi-threading model, the computer hardware needs to be advanced as well. So at the very beginning, we only have a single CPU in the computer system. And within the single CPU, we only have one core there. As the development of a computer technology, so we have a multiple CPUs supported in the computer system, and also we have a multiple cores on each CPU chip. To the operating system, it means that each core appears a separate processor. So therefore, we can assign different threads into different CPU cores to make the computer system support parallelism. And the parallelism means the operating system can perform more than one task simultaneously. For example, like I have drawn the example on the top of this slides. So we have two cores, C1 and C2. Along the time dimension, task T1 and task T2 can be running in C1 and C2 respectively and simultaneously. On the other hand, so we have another concept which is called concurrency. So you need to be very careful about these two concepts because they are very similar, but they are different. So concurrency means the operating system supports more than one task making progress. However, the key word to differentiate these two concepts is the simultaneously. Then let's see an example of a concurrency. So we only have one core C1. There are two tasks T1 and T2 alternatively running in this core. So besides these two tasks, if another task wants to be executed in this core, it can be added without any problems. So from these two examples, you may know that if the operating system supports parallelism, it can also support concurrency for sure. However, if the operating system supports concurrency, it may not be able to support parallelism, just like the second example show you guys. The good example for demonstrating concurrency is that the single CPU with a single core there. The CPU scheduler can alternatively add different tasks onto the CPU to achieve a concurrency feature. Even though multi-threading can provide us a lot of benefits there, however, to implement a multi-threading model is quite challenging for numbers of reasons. So I'm going to introduce an example to demonstrate these challenges. So all you guys may use a Google search engine multiple times to find or learn something from the internet. But do you guys know how did the Google search engine work? And one strategy used by Google search engine is called word counting. So when you want to search something by Google search engine, so first you will type in the keywords that you are looking for, right? So when Google search engine accepts these keywords, it will search billions of web pages to evaluate them and return you the most relevant web pages. So for each web page, it will calculate how many keywords are there, and also for the appeared keywords, so how many times each keyword show up in this web page. So based on these numbers, the Google search engine will do a calculation to generate a score for it. So surely the real Google search engine is much more complicated than this one, but we just use the simplified version to demonstrate the challenges. So this task cannot be achieved with a single CPU computer. If each time the computer can calculate one web page, so you can imagine that how long it will take to evaluate those billions of web pages. So maybe it will take a couple of years. So surely it is not acceptable. Then since we have a more advanced computer, which has a multiple CPUs and multiple cores in there, so we can implement this task through a multi-threading model. Then we will face the first challenge, that is to divide application into separate tasks. So for doing that, the task should be independent of each other and run in parallel on individual cores. For the aforementioned Google search engine example, so we can assign each web page into a thread to do the calculation. However, we may face another challenge, which is a balance problem if we do it this way. So since the size of each web page may vary, so some web pages may be very small, that is with just a couple of tags, but some web pages may be quite large. There may be some videos or pictures there. So in this situation, surely the calculation time in each thread is different. Some thread has been assigned with a smaller web page, it's already finished the task, so while other threads with a larger web page are still executing. So the threads who finish faster will be idle there and waste the system resources. So definitely, based on the web page, may not be a good idea. Then we may think that how about to split the data into equal length in order to achieve load balancing. So for each web page, we can divide the web page into multiple chunks, and maybe 5 lines of a web page as a chunk, then assign the chunks into threads to achieve a better load balancing. However, for most of the web pages, may not be able to divide into integer numbers of chunks. For the last chunk, may only have 1 lines. In order to make the thread get an equal length of a chunk, so you may need to add more lines from other web page. So it can make the task even challenging, right? And the next challenge is data dependency. So for most of the tasks, they can be executed in parallel. However, some tasks they may have a dependency relationship with each other. For example, you have two tasks, A and B. B must be executed after A task finished. Or for the word counting example, since we have divided each web page into multiple chunks, and we must have a sum task to add all the intermediate result from this web page together to get the final result. Under this kind of situation, the sum task must wait all the related tasks to be finished, then do the summation in order to guarantee the correctness. The last challenge is testing and debugging. So this may be the nightmare for multi-core programmers. So since multiple threads are running in parallel, some tasks may run faster, some tasks may run slower. So you cannot guarantee the first instruction of task 1 can finish first, then the first instruction of task 2 can finish second. However, the bug may be only happen under certain orders of combinations. If you cannot repeat the same combination, the bug may not be able to fix. And also, we all have the experience for debugging, right? But under the single thread version, we can do the debug by stepping ways. To divide the entire code into numbers of chunks, then do the debugging on each chunks. However, on multiple core programming, since numbers of threads are running in parallel, so even you only suspend one thread, other threads are still running there. It is very hard for you to do the step-by-step analysis there. So most of the time, only things you can do is through the very basic ways. So you just print out the output either on the screen or into the log file. Then based on the logic to analysis where the bug could be located and fix it. So even though the multi-threading model can provide us a lot of benefits, but you also need to be aware those challenges, because sometimes they require you to spend a lot of efforts to address those challenges.